I'm Glyn Stacey from EBiSC and UK Stem Cell Bank working on the project. Looking at the title from a talk this morning, I realised it probably should have said setting standards to support the quality of research, and that's very much what we're focused on, is not trying to control things but provide freedom to operate with good quality materials and improve the efficiency and quality of your research, so to make things easier for you and avoid problems through our quality control and other activities. So the overview is this, I'll talk about the establishment of this quality control system which supports researchers and academic researchers in industry and industry researchers and their needs. Some of the benefits that are already being realised from the first 2 years of operation and ongoing development in the quality control as well, which is very important. So in looking at the word quality, this is something which is very much in the eye of the beholder. And we have many different kinds of users potentially out there in the field, so we need to address the needs of those different groups of users, particularly the academic researchers and industry researchers. Academia will be often very focused on the speed of supply. How quickly can you get the line to me? Will the cells grow quickly and easily so I can get my research data out? Will the cells perform as described in the original publication? These are really important things. In industry, all of these things are still important. And also that cells perform reliably and they can get replacement stocks that will perform in the same way. But in particular, industry interests also lie in the fact that the cells should not present any business risk to them. So avoiding contamination risks, avoiding the risk of having a lack of informed consent on the cell lines, or any constraints on commercial use are particularly important. There are a number of principles which we've adopted for the development of the EBiSC quality control regime. We've started by building on established standards in good cell culture practice, for example, those developed by the European Centre for Validation of Alternative Methods Task Force, published in 2005, and the ongoing publications by stem cell banks working together through the International Stem Cell Banking Initiative, and we're now contributing to that discussion and building on that. Secondly, QC is performed primarily on post-recovery cultures from individual banked vials. So that's to make sure that any results we report can be interpreted by the user as being what they should see when they recover their own vial of cells that they receive through the post, well, not through the post, but receive from ECAC. Does the cell line do what it says on the tin, essentially? Also, the QC for us needs to be rapid and cost-effective to keep our costs down, but also robust and add value. No good carrying out QC results if they're fundamentally flawed from a sensitivity or reliability perspective. That's no good to the customers. And then we discriminate between critical release tests, which are there designed to avoid hazards to lab workers or to the work itself, for example, from mycoplasma contamination, and separate those from informational characterization tests, which are really there to help inform the researcher on the selection of the cell line for their own particular work. There's also a careful qualification of new QC methods that we're using before they're implemented to ensure that we have progressive and reliable improvement in the QC tests. And finally, we also operate a fairly extensive horizon scanning activity with expert advice from across the project, scientists across the project and in our advisory board on improved methods and other issues which impact on the suitability of our quality control methodologies. The current testing regime is focused on a number of key issues. Firstly, ensuring that we have acceptable viability of morphology through recovering cultures and checking that we have good morphologies, good numbers of cells recovering over a reasonable period of time from a bank vial. Checking that the cell line is the correct cell line by short tandem repeat fingerprint method, matching depositor data with the cell banks that we make, and also ideally right back to the original cells before reprogramming. We're also assuring absence of bacterial and fungal contamination through pharmacopoeia-based sterility testing methods and routine observation of cultures, and in addition a validated mycoplasma qPCR test. There's also a need to assure us absence of serious blood-borne pathogens, and here we're using viral PCR on the cell lines and or donor screening data for HIV, human hepatitis B virus and hepatitis C. We also look at the typical, to check that the cell lines have typical scientific characteristics of iPS cells, so checking by flow cytometry for the early stage embryonic antigens, one for TRA160, OX34, and also PCR for a number of self-renewal genes. And in addition to that, producing expression profiles from spontaneously differentiating embryoid bodies to check for expression of early developmental genes indicating the differentiation to each of the 3 germ layers. And finally, in the last 2 sections, looking for removal of reprogramming vectors by qPCR or endpoint PCR for vector sequence, and checking the characteristics of the genome of the cell line, analysing the karyotype to make sure that more than 70% of the cells have a common genotype, karyotype as reported by the depositor. I also I wanted to mention some of the key issues that we've come across as we've been accepting the first group of cell lines. We've had to resolve a number of cases of switch cell lines, and that's involved quite a huge amount of work for the other people involved in the project to make sure that we have got the right source of cells if we find a problem. But we've got over a lot of those issues. We've also identified and replaced cell lines which have low level or occult bacterial contamination, which could cause huge problems for users in the long run if you have intermittent positive bacterial appearance of bacterial contamination or fungal contamination. And those have been excluded or replaced. We've also been screening the cells, as I mentioned, for differentiation potential in an embryoid body assay, and that's showing up identifying some outlier cell lines which have unusual expression profiles. This is not stopping the cell lines from being released, but it's information that we're passing on to researchers so that they're aware of this, and it will help them select the most appropriate cell lines for their need. So overall, I think our activity, even just to date, we've been able to protect researchers from a considerable amount of wasted time and effort on certain cell lines which are not really suitable for use. I also mentioned that we have a quality control development program that's focused at the moment on looking on 2 areas. Firstly, looking at alternatives to karyology, which can be very challenging to provide on the large numbers of cell lines which we're planning to bank. And here we're looking at we're currently comparing cytogenetics with Baxon bead systems and also array SNPs. And array SNPs are looking very promising at the moment. They give us a lot of information on specific gene deletions, which we don't necessarily get with the other methodologies. But that's a work ongoing. We're also looking at our EB assay. We have a new streamlined and standardized 7-day EB assay for pluripotency, which we're comparing with a number of alternatives, including Pluritest and miRNA expression profiles. And in addition to this, we've also been working with experts in the field to develop a QC regime specifically for the gene-edited lines, which will be coming on stream very shortly. So in conclusion, our QC is implemented to assure the benefits of authentic and contamination-free cells, with the additional benefit of evaluation of differentiation capacity in vitro. We've already screened out a number of particular cell lines which could have led to significant wasted resources and time in research labs or compromised commercial development. EBiSC ongoing is driving QC improvement through evaluation and qualification and implementation of new methods as they arise. And we also aim to assure robustness of our methodologies by using standardized protocols, SOPs, to establish powerful large data sets from the increasing number of iPS cell lines that we're analysing in the project. We're also there to provide advice and support on the QC methods, and that's available through the EBiSC contacts. And in parallel with this, we're running a training program where we're also providing training on some of the quality control methodologies and protocols we use. Finally, it's as Tim mentioned earlier, we do need your input on the quality control programs that we're operating. We want a broad range of input from users and other stakeholders to help us develop that in the longer term. So I'll leave you there. Thank you very much.